guys, thanks for tuning into this fourth and final video when it relates to opacity. Okay, so far we've talked in the first video about four things that can happen to light when it strikes paper and the basic definition of opacity. And then video 2 we talked about TAPPI opacity. Video 3 we talked about ISO opacity. Now in this video we're going to talk more specifically about the kind of dwell on and look at the difference between those two. And then we'll wrap up with talking about how opacity is affected by these guys over here. All right. So a little bit further now on this with these guys over here, we talked about TAPPI opacity being this calculation, R0 divided by R89. Okay, so it was a black cup, and then you have a defined white backing. Okay, sometimes that's called TAPPI opacity. Often you'll hear it called contrast ratio. Basically the same thing when you hear those. All right. In the ISO world, they're using R0 divided by R infinity. They're not using this backing, but what they chose to do is to have an infinite pad of material that's going to be more representative of the viewing environment that this paper is going to be in. So they had a little different methodology in how they go about making that measurement and the calculation. So you have those two things. So this is called ISO opacity. But sometimes you will also see this referred to as printing opacity because it mimics the printing application where you've printed this and now you've got a light material behind it. So doesn't mean you can't do a printing opacity calculation in the TAPPI world, because you can. You can, instead of using the R89 backing, you can use the R infinity backing if you want to do that. So you can calculate a printing opacity from a TAPPI instrument, but it won't agree with an ISO instrument. Why? Because like we defined in the brightness video, for two instruments to agree with others, they have to have this three things in common: geometry, photometry, and spectral response. These have none of those things in common, so they won't agree with one another. So spectral response is different. This one is measuring, ISO is measuring at 557 nanometers. The TAPPI method is measuring at 572 nanometers. Now that's a 15 nanometer difference in the spectrum where they're looking at it. And they're broadband filters, so they cover a lot of range. But the thing we found out through a lot of different studies is if there's a lot of character in that center portion of the spectrum, so the energy change between that can really have a dramatic impact on the opacity between the 2 points. So there is a physical difference in the calculation. There's a difference in the spectral energy response between those. And certainly there's a geometric difference between those two, because we talked about the TAPPI method using the cube. You recall that? And so you've got 15-degree illumination, and that energy is going back into a cube, and then you got a photocell looking in the cube for that. So it's 15-degree illumination, diffuse viewing. The ISO method is kind of just the opposite of that, where you've got a sphere, and you've got diffuse illumination, and you've got 0-degree viewing above that. So the geometric things are there. So just like brightness, or just like color, or anything you're doing, when you are communicating your opacity numbers out to a customer or a sister mill, whatever it might be, it's important that you say, what method am I using? Am I doing the TAPPI method? Am I doing the ISO method? Am I doing contrast ratio? Am I doing printing opacity? You want to make sure you define that whole thing. In our seminar manual, we talk about and we illustrate some of the differences that you'll see in the data between TAPPI versus ISO. And you can't say one is always going to be higher than the other. It kind of is dependent upon the nature of the sample you're measuring. But sometimes you may see as much of a difference as 10 points between a TAPPI opacity and an ISO opacity. That's typically in a more colored sample. If you're dealing with whites and near white papers, you typically don't see that kind of difference. You'll see a difference of 1 or 2, possibly, but you will have a difference between those two. And if you don't communicate that in your specifications, then you're setting yourself up for some heartache unnecessarily, because you didn't effectively say, this is what I'm doing. Does it match what you're doing? Does it match how you evaluate it? Because if it doesn't, then you've just created yourself some hurdles you have to get over that you didn't necessarily have to do so. So some of the basic differences there. Okay, so whether you're measuring ISO or TAPPI method, opacity is still opacity. It is how well does this single sheet of paper or flexible packaging material hide what's behind it, right? So that's ultimately what we're trying to do. Both methods do an effective job of giving you an analytical tool for figuring out where you are and what you need to do. Well, if you're to the point of what you need to do, then you got to go back and start looking at these folks. Say, okay, how do these affect my opacity? And I've done a lot of reading, and I've done a lot of studies around here on each of these, just to really help myself understand a little bit better about these guys. And like I mentioned early on, I've done some things with some samples that we changed their spectral characteristics, the specular component, on that, and really didn't see much of an impact on the opacity of the sheet. So typically, this is kind of a minimal impact. So we'll put an equal sign to that. So if I change the specular characteristics, the specular component of that sample, typically you don't see much difference in opacity. All right. If I come to transmission, though, and if I do something that allows my sheet to transmit more light through it, what do you think would happen to my opacity? Probably you're going to think that my opacity is going to go down, which is true. So if I do something and I change something in the makeup of my paper that makes it light to transmit through it more, the opacity is going to go down. Alternatively, if I do something to keep more light from passing through in that, I'm going to see my opacity go up. So depending on what you do, transmission has a great impact on the eventual opacity that you get. Now, what about absorption? If I do something to cause my sheet to absorb more light energy, okay, so let's say I put a dye in that. Now that dyes by nature absorb light. They are going to take light out, all right? So dyes absorb energy. So if I do something to absorb energy in the sheet, that means there's less energy available to pass through the sheet, right? So if there's less energy to pass through the sheet, that means that sheet's become more opaque. All right, so typically if I do something that increases the absorption, I'm going to see an increase in my opacity. If you have some room in your brightness numbers or your color numbers that you can move the color a little bit, sometimes that is the easiest way to get the opacity you're looking for, is to increase the absorption of the sheet. And then lastly, what happens if I increase the scatter? So what is scatter? It's that air to fiber interface, or air to things that make up the paper interface. Anything I can do to take that light and send it back out again and not allow that light to get through the sheet, I'm going to see an improvement in my opacity. Okay, and there's multiple ways of going about doing that. We're not going to get into this video, but that certainly can have a positive impact on the opacity. These are all true whether you're using the TAPPI method or the ISO method. These are generic in a sense to opacity as a measurement itself. Okay, so changes in specular component typically don't have much impact on the opacity. If I increase transmission, so more light's passing through the sheet, my opacity is going to go down. If I increase the absorption of my sheet, I'm going to see the opacity of my sheet go up, because now I'm taking more light out of the equation. If I increase the scatter of my sheet, I'm going to see my opacity go up, because now I'm sending more light back out and less light can transmit through. Okay, so that is a super quick overview of the difference between TAPPI and ISO opacity. A real quick look at what happens to these key parameters as it relates to light interacting with your paper, and how the opacity of that affects it. And certainly when you look at brightness, you look at your dyes that you're going to do to affect the color of the sheet, all those things are going to have an impact on your brightness, on your opacity as well, because of that absorption characteristics. If you're adding fillers to that, that's going to have an effect on your scattering characteristics, as well as possibly your absorption will affect your transmission as well. Could potentially affect your specular component with that. So depending upon what process you're looking at, what things you're doing, each of those can have some different impact on these guys, which ultimately can then impact and affect your opacity with that. A lot covered right there. Whether it's in this video or some of the previous videos, if you have questions, we love working with our customers. We love helping you solve your situation. So please don't hesitate to give us a call. Don't hesitate to give us an email. We'll be glad to come work with you at your mill, helping you make better paper. Thanks much, guys.